Example 1.11. The electric field components in the figure 1.27 are Ex equal to alpha x to the power half, Ey equal to Ez equal to 0, in which alpha is 800 Newton per coulomb into meter to the power half. Calculate the flux through the cube and the charge within the cube. Assume that alpha equal to 0.1 meter. These are the First, we will realize the question. What are the given values? Ex is given alpha x to the power half and electric field along y-axis equal to z-axis, that is equal to 0. That is, electric field lies only along positive x-axis. Alpha value is given, side of the cube is given. Okay. Flux through the cube, only in x direction there is a field. Therefore, only on left and right faces will contribute for electric flux. Why there is no flux in the y direction and z direction? Because electric field is only along x-axis. If you go for area vector, that is along y-axis here. So area vector and electric field makes an angle theta equal to 90. Therefore, flux is 0. Now, only across this surface and this surface, that is the shaded one. Only across these two faces, you will get the flux. What's the formula for flux? Flux is equal to integral E dot dA. Now we have to consider two faces. First, I will consider the left face. With respect to origin, the left surface is at the distance A. Therefore, x value is A. For the right surface, from the origin, separation is A plus A, that is 2A. Okay. Now, flux through right surface, x equal to 2A. Electric field, first we'll find out formula alpha x to the power 4. Alpha x to the power half. Alpha x value becomes 2A e to the power half. Electric flux is along positive x-axis. Area vector is also along positive x-axis. Therefore, theta becomes 0. Flux is equal to E into area. E is alpha into 2A to the power half into area is A square. Now, we'll go to the left surface. Left surface alpha into A to the power half is the electric field. Electric field is in this direction. Area vector is in this direction. In other words, angle between E and D is equal to 180 degree. Therefore, flux becomes minus E into A. Electric field is alpha A to the power half into A square. Now, we have to get the total flux. Flux is a scalar quantity, right? Now, how to, just you have to add these two fluxes. Total flux equal to flux due to right plus flux due to left. Due to right, how much you got? Alpha 2A to the power half into A square plus of minus alpha A to the power half into A square. Now, we have to simplify. Alpha A square is constant. We will take out root of 2A minus root A. Root A also you can take out root 2 minus 1. If you simplify, A value is given as 0.1. We'll substitute. Alpha value is also given here 0.1. Okay, so A equal to 0.1. A to the power 5 by 2. That is 0.1 to the power 5 by 2. If you simplify, you are getting 3.16 into 10 to the power minus 3. Then root 2 minus 1 is 1.414 minus 1. That is 0.414. Now, flux equal to 800. That is alpha value. Alpha value is given here 800 into A to the power 5 by 2. We simplified as 3.16 10 to the power minus 3 into root 2 minus 1 is 0.414. So, answer is nearly 1.05 Newton meter square per coulomb. This is flux value. Now, what is the charge within the cube? So, we have to go for the charge. Flux is equal to, as per Gauss theorem, flux is equal to total charge enclosed divided by epsilon naught. So, charge enclosed equal to epsilon naught into flux. So, in the previous question, we found the flux as 1.05. So, we'll substitute that value into epsilon naught. So, final answer is 9.3 into 10 to the power minus 2 coulomb. This is the total charge present inside.